So as I looked at your homework quiz, the problems I saw you were having difficulty was with the mean, and this is a standard deviation, and I think these down here might have been standard deviation as well. Yeah, this was standard deviation, and okay, and that's binomial there. Okay, so standard deviation and mean. So let's do a couple of these mean and standard deviation, and that might help you with this particular homework session. Okay, so suppose the discrete random variable of interest x is the number of rolls that result in a composite number when rolling a die 3 times. 4 and 6 are possible composite numbers when rolling a die. Okay, so we want to use this scenario to answer questions, and actually I think the first one I looked at was a mean. Let's go up there. Yeah, same scenario, but we're looking for the mean. Okay, so let's take this to a sheet of paper and let's work this out. Let's remember 4 and 6 are composite numbers. Okay, so first I have to figure out what my sample space looks like, and we have to list that out. So let's notice that what I did was say, okay, what if I just get the composite numbers 4 or 6 on the first die or on one of the die? Well, here I put yes and then not on the other 2 die rolls. And then I just said, okay, it could be though that on the second die roll I got the 4 or the 6, or on the third die roll, and then not on the other 2. And then I said, okay, well, I could have composite numbers on 2 die rolls. So the first 2 being, yes, I got the composite rolls on those 2 die rolls, but didn't get it on the third one. And then, of course, I just moved my y's around so that I got all possibilities where 2 of the die rolls had composite rolls. And then, of course, we could have all 3 of the die roll a 4 or 6. So I just put yes, yes, yes. Or we could not get a 4 or a 6 at all. So that's no, no, no. Okay. So that is my sample space. Okay, now let's think about the possibilities for x. We could have no composite rolls out of any of the 3 dice, so that's a 0. We could have 1 composite roll out of the 3 rolls. We could have 2 composite rolls out of the 3 rolls, or we could have 3. Okay, now this is the harder part. We need to get the probability. So let's talk about the probability of getting no rolls that are composite rolls. That's only this one right here, N. And you might think, well, there's 1 out of 8 of those, but we have to be careful because the probability of getting a 1, 2, 3, and a 5 is higher than the probability of getting a 4 and a 6. So to get this probability, here's what I do. All right, so the probability of getting no composites on, or really a prime number, on the first roll, well, that's a 1, a 2, a 3, or a 5. There are 4 possibilities out of the 6 on the die. The probability of getting the same thing on the second die, or the second roll, is 4 out of 6 again. And the probability of getting the same thing on the third die is 4 out of 6 again. All right, so that's going to give us, if we multiply that together, 4 times 4 times 4 is 64. And 6 times 6 times 6 on the bottom gives 216. And I'll go ahead and make that ugly fraction into a decimal. And that gives 0.296. All right, now I'll go to this after we do our probabilities for each one of them. So let's look at the probability of getting 1 composite roll. That's the ones that have the y, only 1 y in the 3 rolls. Okay, now let's notice that this first one has a probability of, well, the probability of the first y, or the first roll being a composite roll. Well, there's a 4 or a 6, so it's really 2 out of 6, 2 possibilities out of the 6 rolls on the die. Now the probability of getting not getting a composite or getting a prime number for the second roll is 4 out of 6 because there's 4 prime numbers on the die. And then the possibility of getting a prime number for the third roll, again, 4 out of 6. Now, it's actually going to be the same probability when we do this one, because all we're doing is moving around where our composite is. Same thing on this one. So really, if we just multiply this entire thing by 3, we will take care of adding these 3 probabilities together. 3 times all of those. All right, well, if we do that, 3 times 2 times 4 times 4 gives me 96. And then if I multiply the bottom, 6 times 6 times 6 again, that's 216. Let's get that as a decimal. And that is 0.444. Now let's look at the probability of getting 2 of our die rolls that have composite numbers on them. And that's the ones that have the y's twice. So it's this one, this one, this one. Again, there's 3 of them. But let's just compute one of them and we'll multiply it by 3. So looking at the first one, the probability of getting a composite on the first roll, there's a 4 or a 6. So that's 2 possibilities on the die out of 6. Probability of getting a composite on the second roll, again, just 2 possibilities out of 6, and then the probability of not getting a composite or getting a prime on the third roll, well, there's 4 prime numbers on the die, 4 out of 6. So if we multiply that together, 3 times 2 times 2 times 4, it's 48, I believe. And then 6 times 6 times 6 on the bottom is 216. Let's put that into the calculator. That gives me 0.222. And then finally, let's look at the probability of having 3 composite rolls. So 3 4s or 6s. That's our yes, yes, yes right here. All right, so the probability of getting a 4 or a 6 on the first roll is 2 out of 6 possibilities on the die. Probability of getting 4 out of 6 on the second roll is 2 out of 6. And the probability of getting a 4 out of 6 on the third roll is 2 out of 6. So that gives us 8 out of 216. And I'll put that into the calculator and see what that is. Now, all our probabilities should add up to almost or near 1. In this case, it adds up to 0.999, and that's because we rounded these decimals. If we added the 64 2/16, the 96 2/16, the 48 over 216, and the 8 over 216, it would be 216 over 216, or 1, which is what our probability should be. Now, let's get the mean. The mean, we have a formula, and our formula is the sum of the xpx's. That is our formula for the mean for a discrete probability. All right, so what we've got to do is figure out what xpx is. And we're going to do that in this column that I've made over here. So let me get out of the draw feature. If it lets me. Okay, all right, now what we're going to do is multiply the x column times the px column. So 0 times 0.296 is 0. 1 times 0.444 is 0.444. 2 times 0.222 is 0.444. And 3 times 0.037 is 0.111. And now let's add that column up. So I'll need to make a new. And so that column adds up to 0.999. Now, I can guess that that's really 1 because we have rounded here. And if I used fractions, I'm sure that would have come out to 216 over 216. So I'm just going to call it 1. So my mean, let me go back to my draw feature. My mean is 1. All right, now let's do standard deviation because I noticed that was the second problem that you missed on exactly this same distribution. So I'm going to add some columns here. So I've added some columns over here on the right because the computation that we are going to do in order to get the standard deviation, we're going to do the variance, and that formula for a discrete probability distribution is this. It's supposed to be a mu squared, but my drawing is not so good. All right, now notice it has this x squared px, so what we're striving to get is x squared px, but first we need to get x squared. So let's actually do each of these columns. Now x squared, I'm going to go back to my x column, and I'm just going to square everything over here. So 0 squared is 0. 1 squared is 1. 2 squared is 4. And 3 squared is 9. All right, now I need to multiply this column by the probabilities that are in this column. So 0 times 0.296 is 0. 1 times 0.444 is 0.444. 4 times 0.222 is 0.888. And then 0.037 times 9 ends up being 0.333. All right, and then we want to add this column, and that's 1.665. Sorry, my dog's barking in the background. Now we're going to fill in here. Let me go back to my draw feature. The sum of the x squared px column is 1.665, so this is that whole quantity right here. So really, all of this is what was right here. All right, and then I want to take my mean and square it. Our mean is 1, so 1 squared, which is really 1. So I've got 1.665 minus 1 squared. That's 0.665. All right, now this is the variance, and I have to do the square root to get the standard deviation. So I want to take the square root of 0.665, and it will always be the case that the standard deviation is the square root of the variance, no matter what kind of discrete or continuous variable we're looking at. And we get 0.815. So the steps are always going to be the same for a discrete variable to find the mean and to find the standard deviation. The hard part is making all of this right here. This is where people tend to stumble. Now, if it's done for you, which most of your test is probably going to deal with if it asks for a discrete probability, then you just need to know how to make these columns and put things in the right place.